Good evening, everyone. Thank you so much for being here. LinkedIn virtual audience, thank you also for being here. We really appreciate your attendance. In-person audience, there's a few seats. I see one seat in the front row and a couple more up here. Nothing's reserved here, so if you see a seat and you're standing in the back, just grab it. My name is Jackson. I'll be your host this evening. I'm also one of the organizers of AI User Group. AI User Group's a community of professionals interested in the latest AI tools and workflows. And we have 3 professional audiences: marketers, designers, and developers. And we host 3 separate events, and this is AI for Developers. So welcome. Thank you for being here. A few announcements, and we'll just jump right into it. The agenda for today is the first announcement. And first we'll hear from Chauvin, then we'll hear from Jacob, then we'll hear from Shu Wei. At 8 o'clock, we'll have open mic for 5 minutes to kick off networking. So if you'd like to make an announcement, you can stand right here, and we'll just 30-second pitches to introduce yourself before we kick off networking, and that'll be on the live stream too for LinkedIn as well. So that's what we're gonna do. We're gonna have pizza at 8:05, and at 8:50, we're gonna close up the venue. So doors close at 8:50. So thanks very much, and very excited to have you here. I think we should get started with our first speaker. I'm very excited to introduce Chauvin Hassan, software engineer, ex-Patreon, ex-Amazon. The title of Chauvin's talk is Text is All You Need. Without further delay, here is Chauvin.
Me okay? So happy to see you all here, some of my fellow nerds. I just landed this morning from Seattle, and I've really been enjoying soaking up the energy in the city. I used to work a few blocks from here, actually, when I worked at Patreon, and it's really awesome to be back. I'll share a bit more about myself and my background in a second, but I just wanted to show you first what you'll be getting in the next half hour. And what you'll be getting is 4 key ideas that I think are going to revolutionize the way you think about language models. So here they are up front for you. I'm going to prove these ideas with 2 exciting demos, and once we put everything together, you'll realize that today's models are capable of something incredibly valuable that almost no one outside this room knows about yet. So today, we're going to answer a very simple but extraordinarily important question. Can you get a language model to control software? Because if you can do that, then you can have language models solve your problems just by speaking them or typing them. And that unlocks a whole new world of possibilities and actually changes the way we interact with software. So let me give you a few examples. Just last week, I had to delete a bunch of photos in my Google Photos app that I already had in iCloud. It's a boring, mundane task, but I had to do it to free up some storage and save some money on my Google Workspace bill. But it ended up eating an entire evening of my life. Another example. I don't even bother cleaning up my email anymore because it's just such a mess, and I know I'm not the only one. But imagine being able to say, ChatGPT, organize my email, or Claude, book a flight, or Gemini, open a bank account, and actually having a language model finish that task for you in seconds. I think this is an innovation that would be worth trillions of dollars of GDP growth for the entire world. Websites, native apps, and professional desktop software will be seamless to use because we'll be able to control them with natural language, and will all save an enormous amount of time so that at least I can spend my evenings on family, friends, and actually enjoying life instead of deleting photos. So let's start with some history. This is obviously a juicy target, and there have been many attempts to solve this. It was even the promise of voice assistants going back decades. But we saw how that turned out. It didn't turn out great. There's even work on AI agents leveraging function calling, and they're an emerging concept, but for now, they're mostly theory and simply don't work because our models just don't have that kind of reasoning and planning capability yet. There's been some approaches like multi-on, where a model tries to learn user interfaces and use the UI for you, But UI constantly changes, and have you ever watched someone use a UI really slowly? It's incredibly painful. So no to that. GPTs. A few days before the GPT store launched, I predicted it would mostly flop. And I think I was right about that. There are obvious warning signs. It's a closed platform with severely limited capabilities. GPTs can theoretically call APIs, but it's so awkward to do and proprietary, and the UX is so below the bar we're used to that it's no wonder we haven't seen them take off. They're just a minor improvement over plugins, which almost no one used, and OpenAI actually sunset last week. But GPTs are toys compared to what I'm going to show you today. The best solution I've seen so far is actually Vercel's Gen UI concept that they demoed last Tuesday at AI Night. So this is pretty cutting edge. It gets really close with hitting the user experience bar that we're used to with traditional software, but it pigeonholes you into a very specific tech stack using Next.js and React server components. I think it's too inflexible, too coupled between the chat product and the actual product, and it leaves some fundamental problems unsolved. So, as an industry, we're all looking for a solution to this problem of making technology seamless through agentic language models. It would be like making science fiction real, but we keep swinging and we keep missing. But today, we're going to leapfrog all of these solutions that, no disrespect to the amazing smart people working on them, don't actually work. But today, we're going to make it work. And we're going to do it through an open standard that's a win for developers, a win for companies training language models, and most importantly, a win for users. So I hope you're all excited. First, a little bit about me. My name is Shovan Hassan, like that was mentioned before. I was on the payments and risk team at Patreon, building platforms to battle fraud at a large scale. And before that, I was at Amazon in the health and computer vision division on the front-end platform team. I was a front-end engineer there. So I know a thing or two about platforms. I'm on the internet everywhere as Enveo. My website's enveo.com. The best place to talk to me is on Twitter, if you want to connect with me afterwards. I'm also Enveo on there. And of course, I'd love to talk to all of you in person as well. So let's dive into the first idea. And let's start with HTTP. HTTP is a wonderful, battle-tested standard that allows any two computers anywhere in the world to send commands to each other in a fast, efficient, memory-safe way. From this simple standard, we're able to bootstrap the entire internet and the rich multimedia experiences that solve real-world problems that billions of people around the world enjoy every day, like watching movies, shopping online, banking, and more. So I think that HTTP is one of humanity's greatest achievements. HTTP is also just text, really just bytes, strings of ones and zeros. Language models output text. So do you see where I'm going with this? Text is all you need. The capability for language models to control software has existed all along. I'll prove this in the first demo. But before that, I want to prove a couple more things at the same time. I think the software industry has been doing AI completely backwards. Every company building AI features have been running models on computers that the user doesn't trust. And from the user's perspective, models running on other people's machines can't know anything about you, nor should they. I don't trust my authentication tokens and credit card details with Anthropic or OpenAI, and I shouldn't have to. So the interesting problems we could be solving, like having language models cancel subscriptions for us, apply for credit cards, organize our photos, give us directions home, are out of our reach until each company spends years of engineering effort to build, test, and maintain this entirely new arm of their technology stack. And even then, we end up with half-baked features that waste our time more often than they save it. This is called undifferentiated heavy lifting. And it's the reason we haven't seen the Cambrian explosion of AI solutions to our problems that we expected to see over the past year. So do you see how this is fundamentally the wrong computing model? This entire situation hurts developers, it hurts users, and it hurts the creators of language models. What we're missing is an open standard that allows companies to focus on developing their software and being experts in their domain, that allows language models to focus on building the most useful language models, and allows users to get their problems solved easily and securely. Let's talk about the third idea. This is the really big one. In the first demo I have for you, I'm going to prove to you that language models are capable of mapping a user's request to any API that we describe to the model. In a sense, you already know this. Language models already train on documentation for various command line tools like ls and ffmpeg, and are afterwards able to answer questions about them. So what if we created a standard where developers document their website's APIs, make them publicly available, and creators of language models crawl the internet for this documentation and train on them? They can adopt this standard incrementally, starting with even just one endpoint, and if they choose, their entire website. Market forces strongly incentivize these companies to adopt the standard because it opens up an entirely new source of traffic, and will be incentivized to pressure companies training language models to consume their API documentation. And language model companies are incentivized to listen because they're getting pressured on both sides from the companies, and users are going to flock to the language models capable of interfacing with any website through natural language, just because it's so easy to do. So let's hop into the first demo, where I'm going to prove to you a few of these claims. This is a developer conference, so I trust you're all comfortable looking at a terminal. Let me full screen this after copying what I need to. So let's jump into Ollama. Ollama is a way of running state-of-the-art models on your own device. Now, mapping users' requests to appropriate HTTP strings sounds like an advanced capability that might require advanced reasoning. So you might guess that we need a giant multi-trillion parameter model like GPT-4 to do it reliably. But it turns out you actually don't. You don't even need a several hundred billion model parameter like GPT 3.5. And you don't even need a 70 billion parameter model like Llama 2. We're going to do everything today with just a 7 billion parameter model running on this laptop you see in front of you. So let's jump into, I had caps lock on there, into Mixtral. Yeah, let's do Mixtral. Mixtral's pretty good. I actually did this with Mistral. Sure, let's try Mixtral. It's going to take a second to load up. But what we're going to do is we're just going to set the system prompt here. And we're going to paste in this giant thing. But let's just break this down for a second. At the top, we have some contextual information like the current date, and some information about me, like where I live, an auth token for the flight booking service example that we're going to stick to today. And this simulates the kind of information you trust a language model running on your local device with. You could trust it with your credit card, just like you do with your browser. The rest of this system prompt includes an API description for that flight booking website, and that's all this is. And at the end here, we have some basic prompt engineering stuff like if you do a bad job, I'm going to be fired. It seems to help. But enough talking. Let's paste this in and just start interacting with this API. So the website here allows you to book flights. Yeah, it actually gave away the first example where I was going to ask it for a flight to JFK, but so let's just do SF instead. I need to fly to SF tomorrow. And you see it outputs an HTTP string formatted as JSON for readability. And it does a couple key things. It is able to fill out the appropriate departure date in the correct format. So it understands today is March 5th and tomorrow would be March 6th. And it was even able to map the fact that I lived in Seattle to the Seattle airport code. And I was even able to do the same thing for the San Francisco's airport. It also knows I'm pretty cheap and it flies economy. That one, I think, is just the default. So It does a pretty good job of that. And from this simple string, it's only one more step to take this and pass it to my browser to actually fetch this website, which you can all go to right now, and get back some flight information. But the awesome thing here is it's a conversation, so I can keep chatting to it. So if I made a mistake and I say, actually, no, I want to fly to NYC, we should see everything stay the same because it's contextual, but the one thing that it needed to change, it did, and everything else is exactly what I'd expect. And notice how this kind of capability naturally emerges from the model. I didn't have to create a vector database with positive and negative embeddings. I didn't have to upload any documents for retrieval augmented generation. I didn't even have to fine tune it. Imagine how much better this can get if the API definitions are included as part of the model's training set and then RLHF to work flawlessly. In fact, if RLHF sticks around as a method, I can even imagine companies being involved with providing the feedback to make sure things work exactly the way they want for their business. So this is the concept that is the foundation of everything else I'm going to show you today. Let's jump back into the slides. Yeah, sure, let's close that. So let's recap. We proved that given an API definition, a model can map a user's problem, in this case looking for flights, to a string capable of interacting with a website that can solve the user's problem. We proved that this can happen on a model running locally, so we can trust it with private information about us, like where we live and our auth tokens, same as we do with our browsers. And all of this running on the GPU of this MacBook in front of me, not on a stranger's supercomputer on a data center hundreds of miles away. So this kind of functionality is already too cheap to meter. And finally, we proved that from the point of view of the developers of a web application, in order to enable users to interact with our app via natural language, that developer doesn't need to spend weeks or months or apparently even years, as we're seeing the industry slow to move, to build out features and complicate their tech stack. They just need to write a single text file describing the way to use their website. In fact, the thing I pasted into ChatGPT, into Mixtral there, I actually had ChatGPT generated for me. So it took seconds, not months. So these are massive industry-wide problems that we just solved. The final idea is this. But for this one, I think it's best if I just show you what I mean. So let's jump into the second demo and see what this kind of functionality could look like as part of an actual chat product. So, whoops. Let's go to ami.nveo.com. So this is a live website you can all visit today. You can see I was doing some testing before. And let's do the same thing. I need to fly to SF tomorrow. And we see the same output we saw from Mixtral. But when it finishes, we're able to take that string and actually request a website and embed that live website into my chat. So this is loaded in via an iframe, which I'll show you. And you see the fields filled out with the exact values you'd expect. Seattle to San Francisco with tomorrow's date. In fact, it even omitted the return date because I didn't specify it in my original request. So we see 2 flights. These are all made up, obviously. And I want to emphasize, this is a completely different website embedded into my AI chat. And notice I can interact with it as a standalone app. I can even change stuff around, like maybe I want JFK instead, and I want to click around in the UI. Let's change it back to SFO. Or we can type to it. I meant NYC. And the same thing will happen where it changes to JFK, and it updates the UI. And this is a completely live website. I can even see my current bookings, and we can see we have no bookings. In fact, I can even use my browser back button, and it does exactly what you'd want it to do, which is to go back to the page you were on. So the key takeaway here is I don't have to sacrifice a single thing. I can use an app the way I enjoy using an app, which is natural to me, or I can chat with the app. Isn't that incredible? This is possible, by the way, because the destination website in this case, I also made this website. It safe listed the URL of this chat application for cross-origin requests so that the website can put that safeguard in place to protect their users. This is just one of the many security features that you get for free when you build on top of battle-tested standards like HTTP and HTML. This is why I'm not shopping on Amazon for this demo, by the way, although that would be much more interesting. Amazon hasn't safe listed my little chat application yet. So let's do the really meaty thing, which is to actually book a flight. There's been, by my estimation, billions of dollars poured into research and development to make language models capable of doing things in the real world. Useful side effects if you want to be academic about it. But HTTP has been able to do that since the 90s. It's called a post request, and you might have heard of it. But we're going to get a little technical here. To send a post request to book a flight, I need the flight's UUID, and that's a programmatic concern that's not exposed to the user. But I have a trick to solve this. When we fetch this website, what we get back is HTML, and HTML is also text. We can embed that text into the conversation so that the language model has all the context it needs to get the UUID or anything else to map it to the API of the website. So in this case, I've structured the website so that each of these elements are links to the actual flight, and they have the UUID. Let's see if I can dig through these. Yeah, here's the A tag, and you can see the UUID here. It's really small, so let me make that bigger. Oops. And because this text is embedded, and we've described the API of the booking endpoint to include this UUID, if I were to ask it to book the first flight from Seattle to SFO, we see 2. Let's ask it to book the first flight after noon, because I like to sleep in. We should see it start to output a post request with our authorization token this time. And if we were to now go to the bookings endpoint, we now see it's been booked. We were able to do this through post requests. This is a level of productivity that's previously unimaginable. I was able to book a flight with 2 sentences of text. Okay, I think we have time for this. I don't have time to fully dive into this today, but I want to tell you about it anyway. So I completely agree with Logan here that chat is not the end game for AI. I don't know about you, but I find an empty chat box kind of intimidating. Like when you're at the grocery store and you see 30 different types of cereal, I think the way we prefer to use the internet is we all have our favorite websites, and the websites that we use should be center stage. We should just be able to talk with them if we need to. And that functionality should be built into the browser. This will be possible as models get smaller and smaller, and more capable. So, to sum everything up today in one sentence, we proved it's possible to connect any website to any language model. And the magic here is that we did it through an open standard that allows us to get it done in seconds and minutes, not in weeks, months, and years. And the experience users end up with is incredible and makes 0 compromises. So I'm really excited about this idea. I hope you are too. I envision a world where we connect the billions of people on Earth with millions of useful websites that solve our problems. So I want to leave you with a term to encapsulate everything we talked about. we're all familiar with the term API, which is the application programming interface. It's a way for software to describe itself so that other software can use it. And what I showed you today is an evolution of that concept. I call it the application model interface, the AMI. It's a way for software to describe itself so that language models can use it. And rather than replacing any existing software, we're adding a new way to use it, an intelligent way. I think this is an incredibly valuable concept that supercharges the capabilities of language models and the internet, and we can achieve it with minimal effort, incremental adoption, and in a backwards compatible way. In the future, I envision a binary protocol to HTTP, but for native applications like professional desktop software like Adobe Premiere or Excel. So that's really all I have for you today. I'm really glad I came back to San Francisco to give this talk because the builders I've talked to here understand the value of this proposition. Billions of people stand to benefit from ensuring this kind of capabilities as free, open, and easy to develop for as possible. Every internet company stands to benefit from adopting this because users are going to want a way to browse the web just because it's so easy to do it this way. And there's so much more to talk about in terms of security, combating bad actors, and optimizing performance. But for now, I just want to ask you for your help. And the next step is simple. Demand more from the language models you use every day, like ChatGPT and Claude and Gemini. Demand that the complex problems that you have in your day-to-day life can be solved by these language models. And over time, I think these companies will listen, and they'll all agree to an open standard similar to this so that we can all save an enormous amount of time. So thank you.
So we have just a few minutes for Q&A. Any questions for Siobhan? Cool. And just please stand if you can, so everyone can see you.
Yeah, thanks for the talk. Yeah, I just had like a clarifying question. Did you like pass in the API documentation in the context, or did you fine tune your model?
It's just a system prompt, just like the first demo. So you don't even need to fine tune it.
Okay.
That would raise the cost of it, which is a good thing. Ultimately, you'd want to train, you'd want to inject that kind of information at the training stage.
Hey, John, thanks so much for the talk. I was going to ask, difference between an AMI and an API. Do you see there's anything important to change in the way APIs are documented that can optimize them for this use case?
Sorry, could you repeat that?
What changes would you make to an API to make it an AMI that would optimize it for this use case?
Great question. So what's the difference, really? The difference is that when you actually look at the stuff I pasted in, the description for the endpoints were in plain English. So if my screen's still being shared, I can show you a bit more of that. So, oh, wow, this is really tiny. And it's not getting bigger. Let me just paste it in again. Oops. The descriptions for the endpoints were actually written in natural language themselves. And obviously, a regular piece of software can consume that. But that's a perfect way to describe your software for a language model, where you describe the response and the request format in natural language. So that's why this is a separate concept to APIs. Your question.
Siobhan, what was the most frustrating part of setting up this workflow? Was it resolving CORS errors or retrieving the ID?
CORS errors for sure. I was unsure if I would be able to do it. Next.js does not make it easy. I actually have the Next.js documentation bookmarked here. It's my probably most used bookmark.
Okay, let's give Siobhan a round of applause. And Siobhan will be here for networking as well. We're getting set up for our next speaker. I think you're going to be very excited to hear from Jacob. It's going to be a special setup. You'll see.
Okay. Yeah, right. Hello, everyone. Thank you for having me. Um, my name is Jacob. So I'm the creator of Globy. So Globy is the most powerful Gen AI assistant for easy app creation. So if you want to develop any type of software, you talk to Globy. And Globy is not only software engineer. Globy is an artist. So you can draw whatever you want to build and then export code to different programming languages. So, and this is a project that I built a couple of months ago, and since then I do like daily demos, and today we're gonna see what's possible. Well, in this example, I just create like a functional word clock application, and after a few demos, we're also gonna do live demo from Vision Pro. And I have to wear it actually, because if I put it down, we're gonna lose the connection. So, well, so over here, as you can see, Globy generates the code for us. So in this particular example, it connects to OpenAI API, but like the general idea that you can connect your favorite LLM and then like generate code, kind of like build an app this way. So we have like a new version of this on Vision Pro that got approved today for the App Store, and we also have this like offline mode that works on Mistral LLM. So the next example is I'm just building the menu for Office Story game. That's my game that I created 15 years ago, and I'm just asking Globy to create like a simple landing page for this app. And let's see how it does it. So it pretty much also picks up some like relevant pictures, and if you like specify like in the prompt to make it like more functional, so you'll be able to generate some functionality. And this is only kind of like the first version of what we have. So in this example, I'm like rebuilding our website. And it's also it's built on the technology called Globum. So it's globum.com. So I'm like in this example, I'm rebuilding my landing page. I'm asking to make it functional, and I'm like specifying like, hey, if users like press the button, like this happens. And then I also say thank you. I think that's very important to be polite to LLMs. So let's see how this works. So I usually do like daily demos, so like pretty much like 5 days a week, and I put it everywhere. I'm mostly active on Twitter. So yeah, as you can see, it's like Tailwind, JavaScript. So in the next examples, I'll show you how Globy can translate this code to like SwiftUI for iOS or Jetpack Compose for Android. So over here, as you can see, Globy built some like functionality, and it took like pretty much like 30 seconds to build. And this is like a boilerplate, right, that you could take and they could like work on. So the next is like a personal finance app. So I'm just specifying some areas of the like on canvas, and I'm saying like, hey, like build the personal finance app similar to that you could see on this wireframe. yeah, please integrate user-friendly, seamless workflow for premium. Yeah, and yes, again, I'm like very polite, and I'm sending thanks and hugs. So this specific app, it's not only Vision Pro. So we do have this on the website. If you go to globum.com and create an account, you'll be able to do exactly the same thing on the website. So like this is an interesting example. So I'm going to rebuild the settings page from the my iPhone. And I'm saying like, hey, please build this, but do not build what I crossed. So I just like cross the items that I don't want to build, and then I get the code in return. And then this is the final app and the code. So yeah, this is a pretty similar example. So I'm building the like top chart for iOS, and this is one of the apps called Citizenship Test that got to top 1 in education, top 8, and this app was created using our technology called Globum. So this is the top chart we've created. And this is the code that you get. So I think like this demo first got viral on TikTok, and that's how I started doing like daily demos. So that's pretty interesting one. And this is like a unit converter, right? So I'm just like drawing something on canvas, and I'm saying like, hey, build this unit converter and make it functional. And let's see how it does it. So there's some JavaScript. And this is like pretty much like simple apps that you can like get started from, right? So, but next versions that we already currently have and like we're building, making these creations like more and more complex, so you'll be able to ask like follow-up questions. There's also, specifically for Vision Pro, what I like the most is just like, so we've connected these like 3D models to this app, and so you're able to create like multiple kind of like ChatGPT-like windows and attached to like 3D models of developers. So you technically with like Vision Pro, you'll have like a team of agents that like building software kind of like this way, and you can like put this agent like in your kitchen, right? So I can say like now you're like an Android developer, and I want you to work on this app, and I'll come back in like 6 hours and check back on you. So and this is a demo where I generate just simple JavaScript, and then I use Globy GPT. So we have like a custom GPT on ChatGPT. So if you use ChatGPT, you could use it too. So you generate the code this way in the app, and then you ask to translate this code into like a Swift UI project for iOS, or Kotlin Jetpack Compose for Android. So and I just use this. You can do it on the website or like in Vision Pro, but this is like one way of doing this. So you could just like talk to Globy through ChatGPT, and then you get we call it Globum AI extension code. So and basically, to download the template, you create a custom app on globum.com. So we call it, in this example, unit converter. So then you export code the way you want. We support Unity, we support Swift UI, Kotlin, Jetpack Compose, and Flutter. So you open the project in Xcode, and then you just copy paste the code that you get from like Globy GPT or from VisionOS app or for iOS app. And that's how you get your Swift UI project set up, kind of like this way. In the later examples, I think I included the video how you could do it on Vision Pro completely. So yeah, it's pretty much like functional unit converter. And this is the Swift UI code that you get. There's some warnings, so Globy isn't perfect, definitely. So, and this is like a really interesting example of, this is a new version of Globy app that got approved today on the App Store. If you guys are interested in like doing lead code problems, so that's how you could solve it. So I just like attached the screenshot from lead code, and then I asked Globy to solve this problem. And basically, technically how it works, right? So it recognizes the image, and that gives you kind of like the front end for this problem. And this is like longest palindromic substring problem. So it's working, and then that's how you could translate it to different programming languages. So this is like a live demo, live recording from Vision Pro, and that's I just like copy paste this code into lead code website. So this is the Swift solution. So it's this is the Kotlin solution. Yeah, this is Dart for Flutter and C#. Different solutions have like different results over here, runtime and memory. This is another example of building like a habit app. And I think in this one, I'll also translate it to multiple platforms. But first, I generate a web app like this. Press build. And this is kind of, we get the like a habits list, and it's clickable, sounds beautiful. And then we could translate it to, this probably is going to translate it to Swift UI. So yeah, this is like JavaScript. Yeah, this is the translation of exactly the same thing, but like for iOS. And yeah, all you need to do is just like download the project from globum.com, right? And just like replace this code that you get from Globy. And then you run the project, and that you get like exactly the same thing. And again, it's kind of like super fast way for like prototyping things, right? So, but over time, it's getting more and more complex. And that's very exciting. And this one, I just built a couple of days ago.
How is it going?
This is the
I'm doing quite well.
offline
Thank
version
you.
of this. So Globy can work without internet.
What can you do for me?
Globy is here to help you build software projects easily and quickly using Globum's Draw-to-Code software creation tool. I'm designed to assist users, especially those who are less technically inclined, by navigating the platform and guiding them through the software building process. I can also help you with your specific project by generating code within the designated areas of the Globum AI extension's boilerplate projects for various programming languages such as SwiftUI, Next.js, Kotlin Jetpack Compose, Flutter, or Unity for spatial apps. Just let me know how I can assist you, and I'll do my best to help.
I designed Globy to be funny.
Please explain simply and concisely how it works.
And we try to democratize software creation. It's a complex topic, right? So we
All
might try
right,
to make it
let
fun.
me explain it simply and concisely. Globy is designed to help users build software projects easily and quickly using Globum's draw-to-code software creation tool. This process involves the following steps. 1. Design. You can attach your designs or simply draw what you want to build using Globum's software. 2. Export. Once you've designed your software, you can export the code to your preferred programming language, such as JavaScript, Tailwind CSS, Next.js, SwiftUI, Kotlin Jetpack Compose, Flutter, or Unity for spatial apps. 3. Globum AI extensions. Each Globum AI extension's boilerplate project includes a designated area where I, Globy, can help you generate code. This makes it easy and efficient to build your software project. So, just design your software, export the code, and let me help you with any coding needs within the designated areas of the Globum AI extension's boilerplate projects. Let me know if you have any more questions.
So basically, if you build software this way, you can export code and like chat about your project with Globy. So that's the idea. So, and over here, so I'm going to demonstrate the offline mode. And offline mode is interesting because it does work without internet. So, so as you can see, I don't have like OpenAI key connected. And I'm just like downloading Globy compatible model. Globy compatible model, it's like a Mistral-based model, fine-tuned for Globy. So I'm gonna turn off the internet, and I'm gonna build this like 3 buttons. So when it runs like locally on Vision Pro, it is getting like you can recognize that the Vision Pro works really hard. It's like getting heated a little bit, but like generally it works, and it's great. So and the chat is fully powered on this open source model.
Hi there, it's always a pleasure to help out. Are you ready to build something amazing with Globum today?
And so we're getting into kind of final demo where I'm going to demonstrate the full workflow on Vision Pro. And again, it's like available on the website. We also have like a desktop app coming up. So it's pretty much available everywhere. But today's topic is Vision Pro. I would like for you to imagine, how, and kind of show you how you could build this specifically only on Vision Pro. So in this example, I'm just creating the login page, and I'm asking Globy to create like a simple but beautiful login page. Here it is. Now I'm gonna, so this is like our code for JavaScript, and this is our translation to SwiftUI for iOS. So I got the laptop connected to Vision Pro, and I'm just copying and pasting the code for SwiftUI. And this is the project for Android. So this is the Kotlin programming language. So I'm copying this into Android Studio, and I'm just running it on my computer through Vision Pro. And that's exactly kind of the same thing, kind of, it's a little different. So yeah, and that's how we quickly built iOS and Android app. And this is a Flutter code, and Flutter is a framework that you could develop cross-platform apps. It's pretty much on the web, on iOS and Android. And the Flutter kind of works like, like Unity. It's kind of rendering pixels, basically. So, and this is the Flutter version of the same sign up, and kind of like functional. When you press the button, like something is happening. And I'm somewhat excited about this. You know, it's only the beginning, and I'm launching a Globy app and a Globy update on Product Hunt in a couple of weeks. So if you would like to support, you could go to global.com/Globy. We have waitlists for for desktop app. You could become an early supporter. And yeah, you can create an account on global.com, and that's how you get started. And I try to do demos five days a week. The best way to reach out is Twitter. I'm also active on LinkedIn. And now I think it's probably a good time to do something live on Vision Pro. So that's why I was wearing the listing the whole time, because now you could probably. Oh, hello. Okay. Oh, just a second. So let me reopen the app over here. Okay. Maybe we could draw something. Oh, sorry. It's not beautiful. I actually don't know what I'm drawing, but if you guys have any suggestions. So let's do that. Please create the AI user group landing page. So pardon my accent. Landing. Sorry. Okay. Just a second. Here's a group. Landing page. Okay, you could actually type it. So if you have an accent, like me. And this is, by the way, this is not Globy. This is actually like Vision OS functionality, right? So, well, landing page. And let's specify. This is a San Francisco-based AI user group. Okay, and so we're gonna try to build it with OpenAI. So hopefully internet is working, but nothing in this life is guaranteed. So, well, while Globy is building, we could also chat. Chat is fully powered on open source model, and it works locally on the device. Hi, Globy. Sorry. Globy, please explain to everybody how this works, but be concise and funny. Okay. Okay, this is our page we've created. This is the code. We can translate it to multiple programming languages, and we could also edit whatever like we built. So let's see if Globy responded. Well, oh, okay. So, well, Globy responded with some emojis, but also cannot hear its sounds, but thank you, Globy. Be concise, please, and explain how this works. Yeah, I don't know. Like, there's some audio, but it's fine. I think. Oh, you think it goes from? Oh, there we go.
Want to hear from
Delivery slice
Oh,
of
there we go.
pizza. 1. You start by drawing or attaching a picture of what you want your software to look like. This is like giving Globy a blueprint or a recipe for your app, but with your artistic flair too. Globy then takes that picture and uses its AI magic to turn it into code. It's like a secret code generating machine, but way cooler robot face. Painter's palette. 3. The code is then exported to the programming language and framework you've chosen. This is like having a translator that speaks computer and makes sure your app looks and works great across different devices and platforms. 4. If you need any extra coding help, Globy is there for you like a superhero sidekick. It knows exactly where to step in and assist you without messing up your masterpiece. 5. And that's it. You can use Globy for any type of software project, from a cat-themed app cat to a space adventure game rocket. It's like having a personal software building assistant that makes the process as easy as pizza pie slice of pizza.
Okay, yeah, and so basically, yeah, that's the code. You could open the website, you can like press the buttons, and you can also translate it to multiple programming languages, and then launch the same thing on like iOS, Android, and yeah, stuff like that. So that's pretty much that's Globy. If you guys have any questions, let me know. So we're launching in a couple of weeks on Product Hunt. Everything is live. You know, you could try it on the web. You could sign up today.
Any questions for Jacob? Scott?
Hi, Jacob. Thanks for all the work you put into making that demo.
Yeah, thank
I
you.
have a question. Is this for like seeding the UI in your program? For instance, let's say you're building a tool that's going to last for 3 years.
Mhm.
Would you use this to build the first UI, generate the code, and then over time modify the code directly? Or would you go back to Globy to change, to enhance your UI in any way?
I think it's like a perfect way to like get started on software development, right? So, but generally the way I see it, it could be helpful for like people who are already like building things, right? So for, you know, a couple of years, right? And then they, like, if you want to kind of build like a similar project, but like for a different platform, that could be a lot of, like this instrument like that could be like a lot of help. So you could just or like build your idea, or you could maybe attach your designs that you have, or maybe you can attach your code and you can ask to translate it to like a new platform. And what's interesting about this, it's not only, let's say, working with like OpenAI, right? So we're also working like with other like LLMs. You know, we in a couple of weeks we're gonna have like support like Gemini APIs, but also it's like open source large language models that you could you know, set up locally. So if you like care about like privacy of your code, right? So that you can like fine tune like an LLM that's kind of works specifically for the project that you've created for the past, you know, few years, and you can run everything like on your machine or like on your server. I think it's a very good future, you know.
Yeah, yeah. No, and thanks for all the hard work you took putting into those videos. It looked nice.
Thanks.
Any other questions for Jacob? We probably have time for one more.
Oh, hi. Yes, the demo was wonderful. I was very
Thanks.
impressed. So I worked for McKesson for a while. We built an EHR. This is a deep, complex electronic health record system. It's used by, you know, by oncologists and whatnot. Can you? I mean, we've seen small front ends in a couple of demos. How is it possible to build a huge app using this?
So I think I'm curious like what's going to happen in the next 6 months.
Right.
So well, currently it's like a simple application, right? So it also it's possible to do like some like backend work using Next.js, but at this very moment, it's pretty basic, right?
Yeah.
So, but the next versions that we're currently creating, you're able to iterate on these creations, right? So like ask follow-up questions. You could chat about your project. You could say like, hey, in this like specific code, I don't like this, but can we fix that? And it's already possible to do today with something like Globy GPT, right? If you use ChatGPT, you could work on your project with Globy GPT, and it's you could build a very complex app. But like specifically for draw to code, it's really good for prototyping right now.
Right, of course
So
it is. Yeah.
for simple backends too, and the complexity is increasing over time. So well, I hope in 6 months it will be building very complex systems.
Yeah, thank you.
Okay, let's give Jacob a round of applause. Jacob will be here for
Thank you, guys.
networking.
So
So
I also have this like the app on the iPads over here for everybody to try. So if you're interested, I'll be over there. Thanks.
okay, our next presenter, Shuwei Chen, core maintainer and product manager of open source Alexio. The title of Shuwei's talk is Optimizing AI Platform for Automotive ADAS and Autonomous Driving. Please help me welcome Shuwei.
Yeah, thank you, Jackson, for the introduction. And wait a second. Yeah, anyway, Jackson gave me heads up. It always have some stability issue here, but I will talk about stability of the AI infrastructure. It should echo the same here. And I really appreciate Jackson introduced me, and really appreciate the organizer organize this very fantastic meetup tonight. And before we dive into the topic, I would like to give a short introduction about myself. So, actually, I'm nowadays the Alessio core maintainer, and at the same time, I also lead the AI product in the Alessio, this company. Actually, behind this open source project, we do have a commercial company there. So I also lead both the open source effort and also the commercial effort, and to make sure we can deliver the customer and the users a very good user experience. And before joining Alessio, I have already in this we call distribute system area or more than 10 years. I clearly remember 10 years ago, the main topic people still talking about big data. No matter talk about Spark, Hadoop, and the Snowflake, and people thought, wow, it's so fancy. And that's the reason I joined this area at that time. And after 2019, I started do a lot of research together with the production, with the industry, almost every of the big company you can imagine, to adopt this kind of cutting edge technology to the production, including the framework like PyTorch, TensorFlow data, and also a lot of ecosystem around it to provide the data access there. Yeah. Before we dive into today's topic about autonomous driving, I really want to ask one question: how many people here is really a machine learning engineer, develop the model and landing their AI strategy inside the company, or how many people actually also doing the machine learning infrastructure? Because actually, many times when we go outside, given we are infrastructure guy, many people just don't understand what we are doing. Can you guys raise your hand if you really relate to this area? Wow, it's already more than my expectation. Usually, actually, no, last time I go to Seattle, there are almost 100 people there, and no one raising a hand say they are infrastructure engineer. So here, at least, I saw several do the machine learning area. Wow. And actually, we already cooperate with a lot of autonomous driving company for a while, since like 2018, 2017. Like at that time, people still start prototyping their journey, go to the autonomous driving. People still focus on how can I even put a ladder onto my car to get the sensor data back and collect the information. So actually, that's the reason actually, today in the San Francisco city, I haven't been in this city for a long time because you never want to drive from South Bay to here, to be honest. It gave a lot of traffic, back traffic and here. But today I saw the Waymo actually even running there, and they also serve the passenger there. Back to the 5 or 6 years ago, it's very hard to imagine because people still try to put their hardware on their autonomous car, and actually nothing is implemented there. And nowadays, people jump to what we define the stage 2 here. People already start to run a lot of car in production, or they are in very large scale of road testing there. So I put this image here, just make people aware what's the change as a data platform. Because as a top layer, you can see people previous doing hardware enhancement, put every sensor in a car, and nowadays people go to production. I want to emphasize what happened at the lower here, what's the impact to the data platform actually to support this kind of business goal. At the beginning, actually, we start with several or very hot startup like 2018. People say I don't really care about big data. The only thing I want to do is I just buy a NAS solution. I bought a storage, and I also have tens or hundreds of the GPU card. Then I can run almost everything I need on top of this kind of infrastructure. If you come with the big data area, we say if you see you are really large scale, you will see you have more than 10,000 of nodes in your production, then you see very large. But at that day, this is already extreme large scale for the autonomous driving company. Usually it's the data size still at the terabytes level for a single car or 2 cars to do the road testing and get the data back and generate some small model based on the very small volume of the data. And at the second phase, actually, people realize, okay, I already assemble my car with all the sensor, with everything I want to do. I have to develop some software to make it like a platform and to meet our goal. Meet a goal, which means I really want to do some meaningful road testing there. Usually what we saw is people do more than 1 million of the kilometer of the road testing, but usually it's more than the 100 million of the road km of the road testing. At that time, people already start to do some middle scale of the model training there with hundreds of the GPU cards there. And at that time, people also realize given I have so many, maybe tens of the road testing car running there, I need some data pipeline to guarantee I can continuously gather data back from the real working car. For example, if you see the neural car or Waymo car running there, I need some, at least every day or every week, I have to gather all this data back to my AI platform and do the training, generate a better performance of the model, and deploy it back to the Tesla driving car. At that time, we saw people usually have tens or hundreds of the terabytes data for their whole training data set. But nowadays it's very different and also reflect our topic called ADAS. ADAS is, you can think about, if you have hear about the definition of the autonomous driving, they have L1, L2, L3 till the L5. This category mainly for L2 and L2 plus. Almost every time you do the autopilot or this thing, we think it's L2 or ADAS, or L2 plus. At this time, given this situation, a lot of car company already deployed this car in production, like Tesla, Waymo, and also a lot of cars is doing some very meaningful road testing there, which means they already have more than hundreds of cars run the road testing, and also have 100 million of road testing data, all directly from the production data. So when you go to this phase, actually we can call it really large scale of data, because actually the data, whole testing data is already hundreds of petabytes. if you think about many different internet companies, actually their scale is just one scale or two scale larger than this kind of data. But that data is from the whole world of the people. But this data only from maybe hundreds of or thousands of the cars. Actually, it's tremendous large from the scale. And at that time, you have to first of all, you have to deal training with this kind of large of data. At the same time, you also want to build very smooth data pipeline to talk with internal data platform in the data center and external edge, the car, to make sure like you can improve and iterate your product very rapidly. Otherwise, you will like crash by your competitor. It will be a nightmare. Yeah. And back to our story, just to give some ideas what Alashu doing. Alashu never handle the GPU side. So what we focus more still at the data side, how we can move the data, how we can provide the enough or sufficient I/O performance to your GPU to make sure you can achieve your goal, as I mentioned, to resolve the challenge in the previous slides. So we saw actually these certain barriers to effect you to do very effective AI machine learning adoption. The first of all, what we say is like low performance. I will give more detailed architecture afterward, why people say low inefficient data I/O from the existing architecture. And secondly, it's really about the GPU scarcity, because you know, like in autonomous driving, actually it have several different like job, highly related, highly dependent on the GPU training. One is the perception, and also when you generate high quality mapping, and when you do the PAC decision, actually all this kind of decision is the backend is model. We have the deep learning technology or whatever, or even multimodal model to support it. So actually, if that case happen, actually almost every company I talk with, it's very hard for them to find enough GPU in a single cloud or single data center. So they always have to get some GPU from the Azure, get some GPU from the Google Cloud, get some GPU from on-premise, and get some GPU from AWS. They want to get it wherever they want to find this kind of GPU. The last really about cost management. If you see this platform, you will see like only in 5 years, people rapidly only want to do the prototyping to go to production. That definitely a lot of gaps there. Because at the beginning, if you are like an infrastructure guy, I just want to make my internal customer working. So I assemble everything very easily together. But afterward, I saw, okay, I only build a pen, but you want to use this pen to draw like a big picture, like a masterpiece. That's almost impossible. So when people find that, actually, given this situation, they already built the infrastructure there, and this infrastructure is not suited for the extreme large data like processing, and the cost management becomes very important, because you're easily to see for almost every of the autonomous driving company, for the infrastructure part, it can easily increase 10 times or even hundreds of times in 5 years. Okay, at last, we will give some idea how we resolve issue in the real case. But before that, I will give some heads up what is really Alashu meaning and what is Alashu. Yeah. We define Alashu as a data platform, which means we highlight with two different features here. The first feature is called high performance data access, because actually as a caching layer, if your performance is bad, it's no meaning. You just don't want to use it. I add another layer, but actual performance is lower. Why I add it? And second, really, it's reflect to why people. It actually related to people's pinpoint, because we saw it's a lot of data siloed in the autonomous driving and also other industry. So we gave one function called unified global view. What it means of the unified global view? As you see here, actually, we started this open source project like at 2012, actually at AmpLab at Berkeley. So it's a sister project of the Apache Spark. And at that time, we are unifying the view for the different ETL job or the OLAP or OTAP, this kind of engine. Until now, actually, we expand our footprint to the machine learning framework, so including PyTorch, TensorFlow, Ray, actually support them all. If you think about if you are a data scientist, you want to consume some data from S3, you have to write some code to say like, I have to call this S3 API. For example, I get the header, get the bucket first to list all the object I have in this directory and send back to the PyTorch job. And I get every object one by one, feed into our GPU node, then do the training. So, but think about it. This is just for the S3. What if like I have another data in the HDFS, I have another data in the AWS3, so I have to do it again. So on the top layer, actually, we provide some interface like Fuse, HDFS, or S3 for your like application. So which means you never have to change your API from that to adoption in this kind of framework. And on the lower layer, actually, you can see you have a lot of data silos. It may be you use some public data set from the Hugging Face. Maybe it's stored on the S3. Maybe it's stored in your own on-premise data center, HDFS, NAS, or NFS, all this kind of storage. We also provide a connection to all these kind of things. So which means no matter which storage you want to connect to the different application, you basically only want to write one patch of code and handle all of them. So which means you don't have any migration cost. If you reflect to the previous like slide, we said like a GPU scarcity. What we saw is like given you have a lot of application running across a different cloud vendor or with a different portal there, actually it's very easy to migrate your data platform and almost anywhere. Use Alachio plus the Kubernetes to manage the GPU. In our one user, actually they can easily to launch any of the training cluster in any cloud in 10 minutes. Previous, like they have to launch the GPU cluster very quickly, it's under 30 minutes. But actually when they want to migrate the data from the S3 to the GCS, it always takes them like half week or 1 week for a training set. So actually after this kind of change, actually they are easily to migrate almost everywhere to reduce the cost and get the GPU from any cloud vendor. And previous I mentioned like if you are catching a system, there's no performance, then you definitely don't want to use it. So I will dive a little bit deeper into our architecture to illustrate why we are high performance. First of all, there's some performance number here. Give a very straightforward idea how we can do it. We can achieve millisecond latency, 2.5 gigabytes per second throughput plus tens of thousands IOPS. It's usually like under 100 thousands of IOPS per GPU nodes, which means when you scale with your GPU cluster, actually we can perform better. It's almost a linear, under 1,000 of nodes. So which means like it can really help you to overcome the IO bottleneck there. Just give you some idea about the old solution. If you directly connect with object store or using like a NAS solution, actually many of them cannot achieve like a millisecond latency. Give the object store usually handle it for the infinity of the scale out. And also for the cheap like storage. So the latency for them obviously very high. And also at the same time, given hardware like limitation, usually for the single region of the or single available zone of the cloud vendor cloud solution, the throughput is limitation for all the customer, maybe tens of the terabytes per second. So give to the area of the customer. If you are not big customer, you should usually start from gigabytes level. And if you are extreme large company, maybe they give like a terabytes level of the bandwidth. So, but that is definitely not sufficient for the AI machine learning training there. Okay. And another thing is like because we are capturing solution, actually we don't have single point of value. If it's any node actually down, GPU node down for a certain reason, actually we will just fall back. And also it's not will stop your job or it have very limited effect for you. That's the reason I say like joke. Jackson told me like it's a stability issue of the HDMI. I just recall our system. It's very like ridiculous if you face the stability issue there. For example, this morning, startup website down for a while because when I get up, I want to swipe on the Instagram, I found it's totally done. It's like ridiculous, like important for almost every company. We don't want to make you drop down, no matter for the offline job or online job. Okay, and the last most important thing is how we achieve the millisecond latency. Actually, we have one technology we already use more than 5 years is consistent hash ring, like from the client side to find the server side, like data access very easily on the millisecond. Here is some example. Actually, I don't prepare fancy demo today, but I want to give some very straightforward idea how we perform if you compare to the S3 Fuse. Direct access to the S3 to training the ResNet 50. It's kind of very standard benchmark for the computer vision. And as you can see here, if you direct access data in the S3, actually we run this thing for 3 epoch, given the GPU is too expensive. And actually, the GPU utilization you can see is under 20%. So what's the time actually is spent? Actually, it's mainly spent at the data loader, which means they move the data from the S3 into the local disk, then move into the CPU memory. Actually, it's the majority of the time consumed there. So we say this kind of workload is our target, and it's mainly for the I/O bottleneck. So after we add Alagio into as a middle layer there, actually you can see here the GPU utilization comes very high. It's like 93%, and at the same time, the reason you can see why it's happening because data loader become not a bottleneck anymore. It's only 1%. Because like this kind of framework already do very smart things. They do the async loading the data from the storage to the CPU memory, also async to the GPU memory, and also do the GPU processing at the end. But I still see a lot of gap there. Actually, we meet this gap to make sure you don't face any bottlenecks there. It's kind of very simple solution, but have a very good benefit because actually every percent of GPU utilization means tens of dollars every second in many cases. Yeah. And actually, previously I say like we're already very straightforward technology, but I also want to give some idea how we adopt this kind of solution in the user's environment. It's kind of like simplify the architecture from certain of our customer and the user case. As you can see here, people do a lot of like ETL job when they get the data from their car, from the edge, to their data lake house or data house. And they do some pre-processing there. You can think about resizing, you can think about rotation or any of the pre-processing you do there. And they feed this kind of data into the object store. It can be the raw data, which means like the small file, purely small file. And sometimes they put this kind of data to the iceberg table, which make this like more organized to consume for the next consumer. Previously, they used a NAS solution there, but you will feel very weird if you're from big data like area. No one really use NAS in this area. People usually use the object store or HDFS to store data because actually it's cheaper and the scale-wise is much better. But the reason this user have to choose NAS is because almost every object store HDFS provide very poor POSIX interface to the upper layer application. But almost every of the PyTorch or TensorFlow job is running on the POSIX interface. So they have to choose one NAS to do the translation. At the same time, they also prefer high performance NAS. But given the budget limit for this customer, actually they're using the SATA SSD NAS together with the hard drive disk NAS to provide a better scalability with a cheap price there. But quickly they find there are some pinpoint there. First of all, the cloud NAS actually cannot offer enough I/O throughput there. As we mentioned there are some hard requirement at the AI model training. Usually you have to have like millisecond of latency, gigabytes of the throughput they provide to a single node, and also more than tens of thousands of the IOPS you provide to a single node. But Cloud NAS definitely cannot achieve this goal. Actually, when they do the POC, they find for the 1 node or 5 nodes or 10 nodes is still okay. But then when they expand to more than like 20 nodes or 100 of nodes, the NAS quickly become the bottleneck there. So actually make their GPU utilization actually is pretty low. It's only around 30% to 50%. So half of the GPU actually is wasted because of the I/O bottleneck. And secondly, it's very hard to predict. Because previously, if you put everything into the cloud storage, actually you still have a single data lake there, which means you manage your data is still very easy. For example, you know which data you want to keep in your storage and what data you want to remove from this storage. And actually it will help you to do the cost management there. But because they introduced this component, is NAS, actually they have no mechanism can manage the NAS and object store at the same time. Because as you know, like many autonomous driving, actually they have raw data put in. You can see it's unstructured data or even sometimes semi-structured data in your data lake house. It's very hard to imagine how you can like manage this. I know a lot of companies working on the called AI metadata or the AI management of all this data governance thing, but actually, to be honest, I don't see one very successful manage all this kind of data. So which called the data silo there, and they realized after certain like half year and 1 year, almost half of their data move from the object store to the NAS, which is not expected because when they do the model training, the active data is only around like 2% to 5% of the total data set. But nowadays they have already more than 50% of data put into NAS, make their cost management become very hard. So how can they like resolve this issue? Actually, they start from thinking about I have to use a caching solution there. Actually, at the first time, they are not thinking about us, to be honest. They are thinking, I just need a caching mechanism to resolve this issue because as I can see here, I need better performance. I need better like data management between the serving layer and the persistent layer of the storage. So how can I resolve this kind of issue? Then say I need a cache. They even think about Redis at the beginning, but given Redis is purely running on the memory, but it's super expensive because their single training can take hundreds of terabytes of data fed into a training. It's not possible, so they come up with our solution. In the end of the day, actually, they reduce more than 30% time compared to consume the cloud object store directly or compared to consume the data from NAS, which means like they bump up their GPU utilization from 30% to 50% to more than 90% for their critical training job. And at the same time, they also avoid the 50% of data copy there. Previously, they write very complex job between the object store and NAS for each individual task, which means every time you want to run certain job, I initiate a job to copy the data from the object store to the NAS. And when I don't need it, I just delete from that side. But delete usually not happen because you don't know which part is still needed by the customer and your internal customer, and which part actually you can free it very easily. Okay. And the second case, actually, the only difference I saw there, actually, they use all-flash NAS to resolve the performance issue. As you can see here, but all-flash NAS also have another problem because actually most of all-flash NAS is based on the NVMe. Sometimes it's also based on the IDMA to provide better performance. It's a very specialized hardware to provide the performance, which makes the cost is extremely high. Sometimes we can saw for each like storage unit, actually it can be 5 times or even 15 times expensive than the object store, especially when you put the code layer of the object store there. So which makes the cost of the single company can reach tens of $1 million per year to buy this kind of all-flash NAS from the different company. So given the situation nowadays, just think about if you use the ADAS, this kind of system, you have like tens, thousands of cars already running in production. Every car can produce terabytes of the data every day. You can filter it out or not, but actually if the raw data is at terabytes level, and if you want to put all this kind of data into all-flash NAS, it's impossible. And it's just too expensive. Not mean you cannot do it, it's just because too expensive. Then people start to put the data into object store and do the cache management there.
Xiaowei, we have like maybe 1 minute left.
Okay, and this is the last page. And actually, after adopting a caching system, actually they reduce 70% of cost compared to a NAS. And at the same time, they also get rid of the file copy and the file management, evict the data automatically there. we have very active open source community there, and if you are interested to talk with us, join us at Slack. And actually, we have actually today my colleague here is Chan Chan, actually from the community. Actually, answer a question every day there. Feel free to say hi there. Yeah. Yeah.
Well, thank you so much, Shui. We have run out of time for Q&A,
Sure.
but Shui will be here and Chan Chan as well. So go find them during networking, which we will begin right now. And we're going to start open mic announcements. Before we get started, if you had a good time tonight, just mention you were here. Follow us on Twitter and LinkedIn. We have our meetup page, of course. You can find our next events. In fact, we have AI for Developers coming up on April 3rd, so please register for that. And on March 20th, we have AI for Marketers and AI for Designers on March 27th. The agenda is posted, the speakers are posted, so take a look. If you're interested in the content, just come see us. And I think with that, I want to start open mic right now. And so the idea is you just come on up and you can speak to the LinkedIn Live audience as well and just introduce yourself before networking. In fact, I'd like to introduce our first open mic speaker. Sometimes we plan them, usually we don't. But let's hear from Adam Silverman.
Hey guys, my name's Adam. I'm one of the co-founders of AgentOps. You guys might be used to my co-founder Alex Friedman, who usually does these things. But basically, AgentOps is an SDK for building super reliable AI agents. We have a compliance layer, so if anybody's developing AI agents in the room and is interested in figuring out a way to actually bring them to enterprise customers, we'd love to have a conversation. I know this is limited to like a minute or so, but I'll be around basically this entire time. Happy to kind of show you some of the most cutting edge agents. We also run a company called Staff.ai. It's a marketplace, staff with one F, I like to mention. And basically we have this marketplace of all the top agent projects in the space. So a lot of open source stuff for anybody who's interested in building their own, a lot of no code tools if you're interested in that. And the goal here is basically a lot of these companies on staff, they implement our SDK and we actually enable them to go get enterprise sales with large banks and financial institutions. But thank you guys. Oh, whoever's up next.
Awesome. Thanks so much, Adam. And our next open mic announcement is from Yiya Wang. Here's Yiya.
Hi, everyone. Thanks, Jackson. Oh, okay. I have a little note over here. My name is Yiya Wang. I'm an edtech entrepreneur, founder of Future Ed, which is a podcast that explores the future of learning. I'm also a senior at UC Berkeley, studying cognitive science and doing research around AI and education. As a first-gen non-traditional student who took a 7-year gap between high school and college, I've experienced numerous alternatives to formal education. And in educating myself, I've experienced firsthand the transformative power of education technology. And especially for people like me who thrives more in creative and non-rigid learning environment. Most recently, I did a summer internship in Stockholm, Sweden, where the edtech startup teaches kids Python programming in the most imaginative and fun way. That's when I completely fell in love with the space, not the least because people in edtech are some of the most passionate and kind people I've ever met. And so I just kept finding myself wishing that I could spend more time with these people and be surrounded by people in edtech. And so fast forward to today, I am building the first and largest edtech community in Berkeley. It's called BELLY, which stands for Berkeley EdTech and Learning Innovators. And we're committed to doing things differently. Because as cognitive scientists, we're essentially experienced designers. That means we're able to apply principles in human psychology to design unforgettable social experiences. So our upcoming launch event will be on May 2nd. So if you seek more meaning in your current work and envision a future where learning is fun and community-like, I invite you to join us and to participate in our events. Thank you so much.
Thanks, Yiya. Would anyone else like to make an open mic? Come on up.
I do. That gentleman was first.
And just, if you can stand right here.
Right there? Okay. I'll make this short and sweet, just like me. This is Don. I'm from Crudo.ai. We are building an automated recruiting tool which reads PDF or any other kind of document for jobs. Then we'll go into our proprietary database, find the relevant candidate, and then automate a hyper message to them. We know if people like ballet, basketball, Bollywood, we know quite a bit about them, and then we'll use that to help automate emails. We're looking for help on either the machine learning side or the GPT side. We have a working prototype, but anyway, could use more help. Anybody's interested, talk to me afterward.
Thanks very much. All right, next. And if we can limit the announcement to maybe 30 seconds, because in the interest of time, come on up.
Oh, hi everyone. I'm Jason. I am a software engineer. I'm also volunteering with a youth mentorship program. I'm looking for volunteer speakers at an upcoming event about AI careers and technology. So if you see me at this meetup and are interested in speaking to my mentees, please find me with my orange backpack. Additionally, if anyone here is looking for a developer to join their team, whether for a job or a project, please let me know. Again, find me with an orange backpack. I'll be here until 8:30. Thank you.
It's perfect example of an announcement. Thank you, Jason. And up next.
Hi, I want to plug a new development platform. It's called FlowPlay AI. It helps you build LLM-powered applications that are much more complicated than can fit in a single prompt. Sign up for early access at flowplay.ai. Thank you.
Thank you very much.
Thank you.
Hello, Meetup and the internet. My name's Jason. I have a kind of engineering question. I'm working on a project right now, kind of think like tutoring and coaching, and it's helpful to like have more than just one LLM prompt, and it's interesting to have the LLM like figure out what prompt should go next. So if anybody has worked on a project like this and has library suggestions or pattern suggestions, I would love to chat with you. So we've done some like state machine LLM binding stuff, and I would love to nerd out about that.
Thanks very much, Jason.
Hello, everyone. My name is Dwayne. I'm with DACMCU, which is a semiconductor space. Pretty much right now, we have two IPs, one for UART and one for a Wi-Fi and Bluetooth-enabled dev board. And we have a partnership with DigiKey. And if you're looking to buy some semiconductors for your AI project, maybe you want to build like a smart vacuum or a smart microwave or a smart whatever, like we're the way to go. So I just want to put that out there.
Thanks very much. I think we can do like one more.
Thanks, Jackson. All right, I'm here to advertise myself. So I am looking for new roles in ML. A little bit about myself. At my age, my parents left Mexico from a poor town, and they came here so that I could be the first in my family to have a degree in computer science. I have 4 internships. I'll keep it concise. I've interned at a National Science Foundation internship in Puerto Rico. I've interned at MIT, where I've worked on reinforcement learning algorithms. I've worked on the theory of distributed systems. And I also worked at a startup in SF where I shipped code to production. I worked on a bunch of projects, and sometimes I'm funny. Thank you.
Thanks, Alejandro. Great announcement. All right, very last one. Let's make it brief, please. Thank you very much.
Hello, my name is Dmitry. I'm building a company called Fair Compute. And if you need GPUs, like for AI needs, we're happy to help. We're working with a community who have like desktop GPUs as well as with small data center providers. So if you need like A100 or like 4090 at like very competitive pricing, so we can help you. Fair Compute, thank you.
Okay, thanks very much. And finally, Chen Chen.
I'll keep this short. I'm Chan Chan. I'm the developer advocate at Luxio. You just heard Shoei give a little introduction about what Luxio does and some of our use cases. So if you want to learn more, feel free to hit me up. We're also very open to collaborating, whether it's like a guest blog or come speak at one of our meetups, or if you want to co-host, co-organize something, you can find me on LinkedIn. My name is Chan Chan Mao, and I'll be the first search so you can find me. Thank you.
Thanks, Chan Chan. Thank you all for being here, and let's go have some pizza. That's my email address, and appreciate you guys. And LinkedIn Live, thank you very much for sticking with us. See you soon.